Hello everyone, let's start the new topic from the unit of Spur gear, that is wear strength of gear tooth. Now we know that the failure of gear tooth is due to pitting, and this failure occurs when the surface contact stresses are higher than the endurance limit. Endurance limit is nothing but the fatigue limit. So we have seen right here pitting is on the surface of gear tooth. So in order to avoid this type of the failure, the properties of gear tooth like surface properties such as surface hardness should be selected in a such way that wear strength of gear tooth should be more than so here we have the difference between the surface of gear. One is with the pitting, one is the clean surface. So we can select the wear strength of gear tooth should be more than the effective load between the machine tip. The wear analysis of gear tooth is done by the Bukinghams in his paper The Relation of Load to Wear of Gear Teeth, in which Buckingham gives the equation to wear strength of gear tooth. This Buckingham's equation based on the Hertz contact stresses when two cylinders are pressed together, which is shown in figure A and B. So we know that what is Hertz contact stresses. When two cylinders are come in contact, the contact stresses can be given by the normal load. So here is the equation, that is sigma C, that contact stresses is equal to 2P divided by pi BL, where B is equal to 2P into bracket 1 minus of mu square into 1 upon E1 plus 1 upon E2 bracket close divided by pi L into 1 upon D1 plus 1 upon D2, and this term raised to 1/2, where sigma C is nothing but maximum value of compressive stress, which is in Newton per mm square. P is nothing but the force of pressing of two cylinders, so here we have that P. Then B is the half of deformation, so due to this compressive force there is deformation which is shown in this diagram, that is B, figure B. So this total deformation is 2B, which is exaggerated right here. So we know that B is nothing but the half of deformation. Then L is the axial length of the cylinder, D1 D2 are the diameters of two cylinders, E1 E2 are the modular of elasticity of two cylinders, and mu is nothing but the Poisson's ratio. Now you already know that Poisson's ratio is nothing but the lateral strength to the longitudinal strength. Now due to the deformation under the action of this load P, a rectangle surface of the width 2B and length L is length of this cylinder, so it may be like this. So length L is like this, is formed between the two cylinder. Now let's put this value of B in equation 1. Also let's squaring on both sides, so we get sigma C square is equal to, now let's put this B in this equation, so we get 1 upon pi 1 minus of mu square, so this term pi and this 1 minus of mu square taking outside into P upon L, so this P upon L into 1 upon R1 plus 1 upon R2 divided by 1 upon E1 plus 1 upon E2. See this equation carefully. So here we squared on both sides, so this 1/2 get cancelled with the square, and this whole term become the square, so it is 4p square pi square b square l square. So this 2p get cancelled, so what just remains is just 1p and 1l, because 1l is get cancelled, so it is p by l. So here we get 1 upon pi into 1 minus of mu square, because 1 pi is also cancelled. Now this term is, it is just like this, 1 upon e1 plus 1 upon e2 divided by 1 upon d1 plus 1 upon d2. So that term goes again upside. So just we'll just remove, when we replace that d1 by r1, we'll take 1 upon 2 common, so that is again cancel with remaining 2. So because of just square, this become 4p square, so that 2 is cancelled with this 2 and another 2 is cancelled with this 1 upon 2. Okay, write this equation. So let us give the number for this equation. Let us say this is equation 2. Now let's just apply this equation to the gear. So now here in case of cylinder, this R1 and R2 are the radii of two cylinders. Okay, and let us say when we use the steel, this mu become 0.3, that is Poisson's ratio for steel is 0.3. Okay, let's again put this value of mu in this equation. So when we put this 0.3 square here, it become 0.35 P upon L into 1 upon R1 plus 1 upon R2 divided by 1 upon E1 plus 1 upon E2. Let's say this is equation 3. Now in this equation, the contact stresses are based on few assumptions. One is the cylinder are made of isotropic material, that material has identical properties in all direction. Elastic limit of the material is not exceeded is the second assumption, because after exceeding the elastic limit there is a permanent deformation, and here we are considering the elastic deformation. And the last is the dimension R1 and R2 are very very large as compared to the 2B. So this radius of cylinders are very large as compared to this deformation width 2B. That is our third assumption. Now let's apply that equation, this equation 2. Let's replace that cylinder by the gear. Now when we just apply this equation to the gear, we need to do the estimation of radii of curvature or radius of point of contact. So here we have the point of contact which is at pitch point, and radius of curvature of this curve is nothing but the distance from the point of contact to the point of tangency of the base circle. So this is the R2 and this is the R1 for pinion and for gear. Now let's find out value of R1. So let's just consider this triangle. So here we have the perpendicular, this angle is pressure angle alpha, and so the R1 is front side of this pressure angle, so it is dp by 2 into sine of alpha. Similarly R2 is dg by 2 sine of alpha. Now we consider this radii of curvature at pitch point. There is two reasons behind that. First is the wear of teeth generally occurs near the pitch line, so that is the first reason. And when we are considering only one pair of gear tooth carry the entire load, the point of contact occurs at pitch point, and when contact takes place at the top or at the bottom of the tooth, usually two pairs of tooth are in contact. So and the two pairs shares the load. So when we consider one pair is sharing load, the point of contact is at pitch point. Now let's rearrange this equation. Let's do some modification. That is 1 upon R1 plus 1 upon R2 is equal to, so it is 2 upon sine of alpha into bracket 1 upon dp plus 1 upon dg. Let us say this is equation 4. Okay, so we'll do that 1 upon R1 plus 1 upon R2. So this become reverse, so we get 2 upon sine of alpha and into bracket 1 upon dp plus 1 upon dg. Again we know that what is ratio factor in case of gear, that is Q is equal to 2 Tg divided by Tp plus Tg. Ratio factor is applicable for the symmetrical geometry. So here we are going to apply this ratio factor to the number of teeth of pinion and gear. So we'll get this ratio factor. Now let's just put the value of dp is equal to m Tp and dg is equal to m Tg in the equation of Q. So we get Q is equal to, now this instead of this dg we are going to put dp by m. Similarly this dg will put dg by m. So get cancelled, so just remains is 2 dg divided by dp plus dg. Let us say this is equation number 5. So 1 upon dp plus 1 upon dg is equal to dp plus dg divided by dp into dg. We know that. So now just see this equation carefully, or see this term carefully. This term is dp plus dg divided by dg, and here in equation 5 we have this term dg divided by dp plus dg. So this term is inverse of this. So let's put the value q upon 2 in this equation. So it becomes 2 upon q because we have the inverse term. So we can equate this. It becomes 2 upon q. This dp remains as it is. Okay, so we get this 1 upon dp plus 1 upon dg is equal to 2 upon q dp. Let us say equation 6. Now let's put that value of 1 upon dp plus 1 upon dg in equation 4. So we get 1 upon r1 plus 1 upon r2 is equal to this 2 upon sine of alpha remains as it is, and instead of 1 upon dp plus 1 upon dg we just put 2q into dp. So it become 4q dp sine of alpha. Equation number 7. Now we know that force acting along the pitch line is nothing but the normal force. So here we are going to replace this compressive force in case of cylinder, normal force in case of gear, and the normal force in terms of tangential force is Pt upon cos of alpha. We already know this term while studying the force analysis of spur gear. If you haven't seen that video, see that video first, which is given in description box. That playlist is given right there. So let's give the next number for this equation, and now the axial length of cylinder is replaced the face width of gear. As we have seen, this is the axial length in case of cylinder. So in case of gear it is replaced by the face width. Give the next number to this equation. Now put the value of this 1 upon r1 plus 1 upon r2 pn and l in equation number 3. So we get sigma c square is equal to 1 upon 4 pt divided by bq dp sine of alpha cos of alpha 1 upon e1 plus 1 upon e2, which is remains as it is. Okay, so this is our previous equation. So here we put the value of this r is 4 upon q dp sine of alpha, so that 4 is multiplied with this. So, and instead of P we put the PT upon cos of alpha, and instead of L we'll put the B. So it is PT upon cos of alpha B, and that multiplication is done right here in Q dp sine of alpha, remaining term as it is. So here this term sigma square into sine alpha cos alpha into 1 upon E1 plus 1 upon E2 divided by 1.4 is nothing but the load stress factor, that is K. And so the equation become PT is equal to this PT, this term goes on another side, PQ dP into K. So this equation gives the relationship between the tangential force and corresponding contact stresses. Now when this tangential force increased, the contact stresses also increases, and pitting occurs when this contact stresses reaches the magnitude of surface endurance strength. Therefore we can say that wear strength is maximum value of tangential force that can tooth transmit without the pitting failure. So SW is equal to BQ dP K, where SW is the wear strength of the gear and sigma C is the surface endurance strength of the material. And note is this load stress factor for steel. When we put all the terms or all the values in this equation, we'll get 0.16 BHN divided by 100 bracket square for stainless steel. Also when pressure angle is 20 degree. So I hope you get the concept of wear strength equation of the gear tooth, or Buckingham's equation of wear strength for the gear. Thank you for watching video.